All right, this is problem 27. It says starting from rest, a 12 centimeter diameter or 0.06 meter radius compact disc takes 3 seconds, so the time is 3 seconds, to reach its operating angular velocity of 2,000 RPMs. So omega is equal to 2,000 RPMs. Omega initial is equal to 0 RPMs. So it goes from stop to 2,000 RPMs in 3 seconds. Assume that the angular acceleration is constant. The disk moment of inertia they give you, I, is equal to 2.5 times 10 to the negative fifth kilogram meter squared. All right, and we want to know what is the net torque. And how many revolutions does it make before reaching full speed? All right, so there's several ways to approach this. What we want to know is the net torque. Well, we know from Newton's second law that the net torque is equal to I alpha. Well, we have I, so we just need alpha. But they said alpha was constant, so that helps us out. We can use our constant acceleration equations. Remember, omega is equal to omega naught plus alpha t. We can figure out what alpha is because we know the time. We know omega naught. We can solve that for alpha. We plug that back in, we get the net torque. So to do that, we're going to just say, okay, let's solve this for alpha. Alpha is equal to omega minus omega naught divided by t. Or in this case, we have to convert because we want it to be in radians per second squared. So up here, I'm going to convert 2,000 revolutions per minute. And remember, I have minutes on the top, 60 seconds on the bottom, and I have 2 pi radians over 1 revolution so that the revolutions cancel and the minutes cancel. And when you do that, you get that the omega final is equal to 209.4 radians per second. So I'm going to have 209.4 minus this is 0 divided by 3. And when I do that, I get that alpha equals 69.8 radians per second squared. Which means the net torque is going to be equal to 2.5 times 10 to the minus fifth times 69.8. You multiply that out, you get that the net torque is equal to 0.0017 Newton meters. That's part A. Part B, they asked how many revolutions. Well, since it was a constant alpha, we can just plug that into our equation here, omega naught plus omega naught t, plus 1/2 alpha t squared. So we have theta equals theta naught plus omega naught t plus 1/2 alpha t squared. That's one of our constant acceleration equations we've used for a long time. Well, this was 0, this was 0, so theta is just equal to 1/2 alpha t squared. When theta is equal to 1/2, we have alphas right here, 69.8 times t squared, which is 3 squared. When we do that, we get theta is equal to 314.1 radians. But they don't want it in radians, they want it in revolutions. So we got 2 pi radians is equal to 1 revolution. So I divide that by 2 pi, and I get 50 revolutions. So it spins 50 times to accelerate from 0 to 2,000 RPMs in 3 seconds. All right, that's the end of number 27.